Alright, and in previous video we actually talk about we actually left with this one, right? And we haven't talked about this. And the reason is that in fact, just in the previous video we write it as vi w ij, right? So previously we actually where's my pen? Okay, we actually write things in terms of this manner. But however, one problem with this is that I actually forgotten that we cannot do that, alright? Because in vi, right, vi itself it's v1, v2, v3. If it's in the n times m row times column, this is actually 3 rows times 1 column. While the matrix of wij, alright, this one, is in terms of 3 times 3. So a 3 times 1 with a 3 times 3 can never be together because this one has to be the same as this one. Alright, this is a rule of the matrix that I just want to convey. So one way is to ensure that, because we can also write that vi transpose, we can actually solve the equation, but we just don't want to do that. Alright, so what we can do is to just simply bring this vi to the back. So I'll have this form. And therefore this meaning is simply stating that the tensor wij, alright, this stress is acting on a certain vector plane, alright, or certain axis of a vector v1, v2 and v3, alright. And therefore, so in this case we have 3 times 3 and 3 times 1. So 3 times 3 and 3, they are the same, and therefore 3 and 1 is the result of here. Alright, so in a certain sense they cancel each other, so we only left 3 and 1, which is why I've written this over here. Alright, so I hope this is pretty much clear for you. And therefore, let's continue with the matrix multiplications. Alright, so for the matrix multiplication for this 3 times 3 and 3 times 1 is that w11 multiplied by v1 is over here, plus w12 multiplied by v2 is over here, and w13 multiplied by v3 is over here. So it's just a summation of them together, or like this. Alright, so for the subsequent rows, we will just do out the same thing. Okay, it's just simply the matrix multiplications. That's all. Okay, it's pretty straightforward. I didn't cheat you for any feelings. And therefore, that being the case, what can we see? We can see a certain trend. Alright, so where's my pen again? Here. Okay, so therefore you can see that 1, 1, 2, 2, 3, 3. They are always the same. Alright, so therefore these are the dummy indices. Alright, they are actually appear twice in a row, or twice in one time. Alright, so therefore from this case we can see that this path over here is always the same. Alright, and then this path here is always the same. So we can actually rewrite things in a way such that it's pretty cool. Alright, so what we can do is to write wij vi. Alright, this is the actual thing like this. Right, but instead of doing that, we know that this whole thing is the x-axis, this whole thing is the y-axis, this whole thing is the z-axis. If you talk about vectors, alright, it's just the same thing. Alright, so they are just summing up the directions of each one. So this one is one vector. Is if you talk about the axis, some vectors going spanning in x, y and z. For this case, alright, for this row case, they have another vectors. For this case, it has another vectors. Alright, so I'm simply taking all this things together. So I'm just trying to represent each of the row with a generalized answer. Alright, so the generalized answer is, however, therefore be wx, I call this j, and then vx, right, since is in the x-axis 1 1. I'll just call it that, and then plus w y j vj, alright, plus w sorry, this shouldn't be j, but this should be y, alright, plus w z zj vz. Okay, so simply this is the form of a, because this is a 3 by 1, therefore can state this thing, which is equals to wij vi. So I is always the same. In this case, I'll just highlight with. So they are always the same. So in here it's x and x. In here it's y and y. Alright, I didn't change you for any feelings. And so forth. And thereby, the only changing things are the j's. Right, as you can see, are the j's. So the changing thing is always the j's. Alright, in terms of each of the numbers across this line. Alright, so j is changing from 1 to 2 to 3, and then for the next vector changing from 1 to 2 to 3 again. Alright, this is the meaning of that. Alright, so you may wonder what the hell are all these things like that. This is just simply getting a tensor, multiplying a tensor on the vector. Alright, and this is one of the few operations that we will discuss later on in the later videos. So this, just to let you know that this is the understanding of a getting things in terms of the generalized equation, and the purpose is to actually cut down, or we can call it the economy of writing. Reason is because if you're writing codes in SolidWorks, ANSYS, Arduino and softwares like this, you get to know that having to represent things easily and efficiently can actually save a lot of data. Alright, and this all it all counts, and therefore this is the thing that I want to convey. So I shall see you soon. And yeah, hold on. So to conclude, alright, to conclude is that tensors, we have cleared away the definitions and initial notation, and we also give you a clear understanding of initial notation definitions. Maybe not, I think next video. And then summation rule, and free index and dummy index. Right, so in the next video we'll talk about the rest of it, the symmetry writing and stuff like that. Alright, so and then we will clear away the definition of tensors, and we will move on to operations and stuff like that. I shall see you there.